The key word in problem M.2.9 is distance. You may be tempted to think this is a slope problem or an intercept problem or a midpoint problem because you have 2 points. But the key is to make sure you understand that distance is what's being asked for. And the way to find the distance between 2 points is to use the distance formula. Now, if you're not sure how to use this formula or not, you haven't memorized it, you could do this directly in the coordinate plane itself by graphing those points and then finding the distance between them and then using the Pythagorean theorem. I find this way to be easier and quicker, but it does require memorization of the formula. And so the formula is going to be x1 minus x2 squared plus the quantity y1 minus y2 squared, and all of that is underneath the square root. And to figure out what these x's and y's are talking about, we just label them right here in the problem. This is our first point, so this is x1, y1, and this is our second point, so this is x2, y2. And when I plug this information into the formula, you get the square root of negative 2 minus 1 squared plus 4 minus negative 2, which is plus 2, squared. When I simplify that, we're going to get negative 3 squared plus 6 squared, which is equal to 9 plus 36, which when we simplify and break that down is equal to the square root of 45. Now we see that that is not a choice here, so there's 2 things you could do. One is you could just put all of these into your calculator and see which of these is equivalent to the square root of 45, or you could break this down and simplify the radical by recognizing that the square root of 45 is the same thing as the square root of 9 times the square root of 5, and I broke it down this way because 9 is a perfect square. And so I'm going to see this as the square root of 9 times the square root of 5, because I can break it down like this as well. This actually equals 3, so the simplified radical is 3 square root 5, and that is actually an answer choice over here, so we didn't need to use our calculator to do that. So again, the strategy for this problem, whenever you see distance, is to use the distance formula. If you don't memorize it, then you're going to actually end up doing something way more complicated, where you are using these points, finding the vertical and horizontal distance, and then using the Pythagorean theorem to find the length of that line. It's the exact same thing. This is just faster.